Today we'll be covering how to insert two USB TC01 DACs in LabView and collect data and save it. So we'll go ahead and open LabView. I'm going to open a new folder or a new file using Control-N. And the first thing I'm going to do is insert a DAC. Go to Express, Input, DAC Assistant. Then I'm going to go to Acquire Signal, Analog, Temperature, and Thermocouple. I'm going to select my first Thermocouple DAC with the only single channel we have. And I'm going to change the maximum range to 200 because we are collecting signal at 100 degrees C, which is boiling water. The first thermocouple type is a T-type, and co-junction compensation is built in. Now you notice that one sample on demand is the acquisition type for this thermocouple DAC. Now we can only insert one thermocouple DAC per DAC assistant, so we're going to have to insert another DAC assistant. So we're going to go ahead and go in, Express, Input, DAC Assistant. I'm going to Acquire Signal, Analog Input, Temperature, Thermocouple, and choose a second device's channel. And again, we're going to change this to 200. Now the second thermocouple type is J, so we're going to keep that as J and do built-in, and you again see that it shows one sample on demand. Now what one sample on demand means that it will take one sample, stop, take another sample, stop, take another sample, stop. So in order to create a plot for this, we need to create a waveform chart. And what a waveform chart does is it will take the previous data and add another point on the same chart. So I'm going to go ahead and connect the output of the first thermocouple to the waveform chart and the second thermocouple to the waveform chart, and you notice it automatically does merge signal to the waveform chart. Now, what we need to do is, in order to run this, you'll see that when I hit run, it only gives you one value. Then you hit run again, and it'll give you a second value. You hit run, and it only collects one sample at a time. So you would see that if I had a waveform graph, it would not show the samples. Now you can see I have a white and a red line. The white line corresponds to the top thermocouple DAC, and the red line corresponds to the bottom thermocouple DAC. So the top one's a T-type, the bottom one's a J-type. So what we can do is, if you go over here by plot and expand it, you'll see like a legend. We can change the names of this by right-clicking, go into Properties, go to Plots, then do not use waveform names for plot names. And plot 0 is the first one, which is T-type thermocouple. And then go to plot 1, which is our J-type thermocouple. So I'll say J-type thermocouple. So now we have a legend that tells us which thermocouple is which in the waveform chart. Now, since when we hit run, it only collects one sample and then stops, we need to put this in a loop in order to collect multiple data points. So you're going to go right-click, you're going to go to Express, Execution Control, While Loop, and you're going to drag a box around your two DACs and your waveform chart. Now, we don't actually want a while loop, so we got to delete the while loop, right-click on the border, select the border right-click, and replace with for loop. So now it's a for loop, which means that it will collect samples starting at 0 up to a number of iterations. So we want to define how many samples it collects by creating a control for the iteration count. So this is our maximum iteration, so I'm going to go ahead and name it maximum iteration. This is the equivalent of number of samples we want. And then down here we can create an indicator for the iteration count. So that way it will tell us what iteration we're at. So if we go to the front panel, and I organize this so we can see what it is. So I got a control for maximum iteration count, and then I have a iteration count indicator. Now the way the iteration count works on LabView is that the count starts at 0 and then increases from there. So if I want 100 iterations, the final iteration count is going to be 99. So if I go ahead and hit run, you can see that it's collecting multiple samples now, and it's at 22, 23, 24, 25, 26, and it keeps on collecting samples. And it's going to keep on collecting them until we get to 100 samples, or 99 in iteration counts because it starts at 0. And now you can see it stopped. Now the next thing we need is we need to be able to control the interval between at which samples are collected. To do that, you right-click, go to Express, Execution Control, and Time Delay. Now I'm going to create a control for time delay, and I'm going to put it on the front panel. Now the time delay is another method of saying hertz because it's 1/seconds. Now the thermocouple decks you have can only sample at a rate of 4 hertz, which means 4 samples per second, which is equivalent to a delay time of 0.25. So if I insert 0.25 for 10 iterations, that means it's going to collect for about 2.5 seconds. So I go ahead and hit run. Excuse me. And you can see that it collected the data. Now I can increase the delay time, which means that every half second is now collecting a sample. So it's going to take about 5 seconds to collect data instead of about 2.5. Now we don't want to just be able to see the chart. We actually want to see some numbers. And in order to do that, we need to insert a block called collection. And that's under Express, Signal Manipulation, Collector. And you're going to need one for each signal, one for the T, one for the J. And what we're going to do is you're going to set this to the default 1,000 samples as the maximum number of samples that it'll collect. And you're going to connect the first part, the signals into it, from the 2 DACs, and then the output will be a collection of all 100 data points, because initially what's coming through this DAC here is one data point at a time based on the time delay. So every 0.5 seconds one data point is coming through and then being displayed on the chart. Now what the collector does is it takes those data points and stores them in an array and then returns the full array at the end of each iteration. So it'll take the first value, then the first value and the next value, and it'll keep on displaying it. So you'll see your mean changing as you're collecting. Now, we want to display the mean and standard deviation so we can get some statistics about the temperatures we're reading. So I'm going to insert two standard deviation blocks because it's got both the mean and standard deviation in it. And I'm going to connect these to the output of the signal collector. And then I'm going to create an indicator for the mean. And I'm going to call this T-type mean, because then I know that it's a T-type thermocouple mean. And then I'm going to create an indicator for the standard deviation. And I'm going to call this T-type standard deviation. I'm just going to abbreviate it. And then I'm going to copy these two labels to the J-type, and then I'm going to fix it by changing T to J. Then I'm going to go to my front panel and reorganize it. So I have my T-type mean on the left here, followed by my T-type standard deviation. And then I have my J-type mean, followed by my J-type standard deviation. Now again, remember that when you insert indicator on the block diagram, you should, if you're not able to see any results, you need to right click on that indicator, go to Properties, Display Format, and then you change the 2 to a higher number such as 4. So instead of showing 2 decimal places, it shows 4 decimal places. And you can do that with all 4 of them. So now when I hit run, I'm going to collect 10 samples with the interval of 0.5 seconds, and then it's going to stop. And that final mean and that final standard deviation is the standard deviation and mean for the entire 10 samples. So now that we are able to display the temperature in a chart and then as well as in a mean and a standard deviation, we want to be able to save this data. So to save this data, we got to insert our right to measurements file. So that's on output, right to measurements. Now, I'm going to select one column only for time, use next available file name, and I'm going to save it on my desktop as the normal test.lvm. And I'm going to hit OK. So the first thing I'm going to do is I'm going to merge the two signals for the two thermocouples. That way we have the time column, the first time column that corresponds to the X and Y values, basically two channels. Then I'm going to add in my thermocouple means and standard deviations. So I'm going to start with a t-type. Then I'm going to do the standard deviation and then the mean and standard deviation. And then I'm going to do the j-type, mean and standard deviation. Now the next thing we want to save is you want to add in the delay time as a parameter to save. And the main reason you want to do that is that it tells you the time between each sample being taken. And when you look at your Excel spreadsheet, it'll have the values labeled as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, in order to change those into a time variable, you would have to convert the number by multiplying it by the delay time. 0 would be 0, 1 would be 0.5, then 1, then 1.5, 2 if you had a delay time of 0.5. Now I'm going to create my normal controls of the file, and then the normal indicators is file out, and if I'm saving data. Now with the for loop, there comes a little issue when you save the data, and I'm going to show you that right now. So when you hit run, it's going to keep on making a bunch of different files. So when I open it, you're going to see that it keeps on doing a header every time because every iteration is collecting that value. And if you have enough iterations, it'll create a bunch of files since you said use next available file name. Now all we want is just this last one right here. You see here, this one has all 10 data points, but it starts saving everything from 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we're going to do is we're going to create a little Boolean, or should I say conditional statement, to tell it when to save. And we're going to do that by first inserting a numeric subtraction, and we're going to create a constant of 1. And we're going to connect the first part of it to our max iteration count, so our n number of samples. And the reason why we're doing n minus 1 is that the iteration count starts at 0. So the first iteration is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I have 10 iterations when I type in 10, I want 10 samples. Then 10 minus 1 is 9. So that means that when the iteration count is equal to 9, n minus 1 is 9. So that's when I have all my data collected. Since my maximum iteration count is 10, but they start the iteration count at 0, therefore 10 minus 1 is 9. And the iteration count, the last iteration count for 10 iterations is 9. I'm going to create an equals because I want it to save a file at the very last iteration when all information has been received. So I go into express, arithmetic and comparison, and equals. And what I'm going to say is if the iteration control is equal to the maximum iterations minus 1, or the iteration count is equal to, if it's equal to the maximum iteration minus 1, then I want to do something. And the thing that I want to do is I want it to create a selector, which means that it will be one value if it's true and another value if it's false. So the output of this is a Boolean, true or false. If it's true, it'll send this top node through to this right side. If it's false, it'll send the bottom node through. And what I'm going to attach to the top and bottom nodes is a true and a false constant. So I'm going to go ahead and copy that constant, and then I'm going to make sure I click on it so it says true. And the true constant I want to go through if it's equal, and false I want it to go through if it's not equal. And I'm going to hook the end of this selector based on our Boolean to our enable. And what this will do is that when this iteration count is equal to our maximum iteration minus 1, so if you want 100 samples, iteration count starts at 0. The last iteration count, or 100th iteration, is 99. So if the iteration count is equal to 99, then I want this to be true, which means that it enables the write to measurements file to save. Else I want it false. That way when I hit run, which I'll do right now, I won't get that, what we saw before in the Excel file. I'll just get the one set of complete data, not 1 was 0, then 1, 2, 3, 4, 5, 6, 7 extra points in it. So now when I open test 1, I'll see that it has all 10 data points already in it as a single one. So you can see here it has all 10 data points shown here. Now, I can rename my signals using the dynamic attributes method, like we have done for the past 2 labs. And I'm going to go ahead and insert that in after the merge, make it a little bit easier for me to manage everything. So I'm going to go ahead and move things around on here. And then I need 1, 2, 3, 4, 5, 6, 7 different dynamic attributes. So I'm going to go ahead and go to Express, Signal Manipulation, Set Attributes. I'm going to insert it. I'm going to do signal name and X dimension. And don't forget you have to do your signal index of which signal you want to modify. I'm going to go ahead and make a copy of it, as I need 7 of them. Now I have 6, 7. And I'm going to delete this wire going from my write to measurements. And I'm going to connect the final output to write to measurements. And then I'm going to connect this signal input to output, 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 input to the merge. I'm going to go ahead and rearrange this a little bit so it's a little bit neater and give myself some space to put in the controls. And then go ahead and move everything to the right a little bit so I have a little extra room. And now I'm going to go ahead and insert my constant, insert constant, insert constant. And this one, for the first one, it's in temperature. And that is not a choice. I'm just going to say no units. So I'm going to go ahead and not use my X dimension on all these. I'm just going to ignore it. So this first signal is T-type values, or T-type thermocouple. Then I'm going to go ahead and take that, copy the 2 constants, move them over here, connect them to the signal index, signal name. I'm going to make this signal 1, and the next signal is J-type. And then I'm going to repaste the 2 constants again, connect the signal index, go to 1, connect the signal name, and this is T-type mean. And then I'm going to go ahead and copy these 2. This index is supposed to be 2. Go ahead and copy these 2 again, and move this over a little bit, and put the 2 values over here. Go ahead and change this to 2, and then copy and paste them. Move this to the right a little bit. move these over here. Do the signal name, signal index, and the signal index is 3. And this is T-type standard deviation. And then I'm going to do it for this next signal, and this one's 4. And this is J-type mean. And paste it again. And this one's 5. And this is J-type standard deviation. And then one more time pasting it. And this is 6. And this is sample time interval. And you go to signal index and signal name. And then now go ahead, I forgot to connect 2 of them. So I go ahead and connect the 2, and then I go back and rerun it. It'll be test underscore 2 underscore 3 on the final iteration. And then I'll go ahead and open that. And then you can see that all of them have been labeled properly. So now you know how to label them and collect samples using the thermocouple DEX with 2 of them, and using a for loop with the iteration count to make your number of samples, and that create a Boolean to see if the sample iteration count is equal to maximum samples, and if it is, save the right to measurements file this time with the column names. How you set up your VI so you can collect samples for 2 different thermocouples at the same time.